Okay, so the last thing that we're going to cover are two things that help us figure out how to find the zeros of these high order polynomials. So we have synthetic division. We know that if we get a zero, that we have as a remainder that we found a root, we found a zero of the polynomial. So then the question becomes, well, how do we even know where to start? I mean, there's infinite numbers, infinite possibilities. What do we do? Well, it turns out that there's not so much infinite possibilities. There's two things that help us restrict down what to pick and how to pick. So the first is Descartes' rule of signs. And Descartes' rule of signs says it helps us figure out how many possible positive real solutions that we have, rational solutions, and how many actual negative solutions. Okay, so if you have a polynomial for Descartes, so we have y is equal to 3x to the third minus 5x squared plus 2x minus 7. If we want to know the number of actual positives, we count the sign changes, okay? So if I want to know positive, I count the sign changes of the polynomial, meaning positive 3 to negative 5 is a sign change, negative 5 to positive 2 is a sign change, and positive 2 to negative 7 is a sign change. So we have 3, and then we write or 1. Okay, every time you do Descartes' rule of signs, you're going to subtract 2 until you get to 1 or 0. Now, the reason you subtract 2 is because two very important reasons. Imaginary solutions and irrational solutions come in pairs. Okay, so if you remember the quadratic formula, x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. When we do this, we inherently have two solutions right there, 1 plus, 1 minus. Okay, so if we have an imaginary solution, it has to come in a pair. Okay, and we're going to talk about how to figure out the possible imaginary solutions as well. Okay, so you're always going to subtract 2, just a rule. However many sign changes you have, you subtract 2 till you get to 1 or 0. That should be fairly obvious because you're not going to have negative number of solutions, so it's either 1 or 0. Okay, if I want to know the number of negative solutions, I have to plug in a negative x, simplify, and then count those sign changes. So y is equal to 3 times negative x cubed minus 5 times negative x squared plus 2 times negative x minus 7. Okay, so I have y is equal to a negative cubed is a negative, so it's negative 3x cubed. A negative squared is a positive, times a negative 5 is still negative. 2 times a negative is negative, and then the last constant doesn't change. So we count the sign changes. Now notice there's no sign change. Every single term is negative, so that tells me there are 0 negative solutions. Now how is this helpful? Well, this is helpful because in just a second we're going to learn, the very next slide, we're going to learn how to have a limited pool of numbers to pick from. So now I've cut that pool in half because I know that there's no point in picking a negative number because the Descartes' rule of signs tells me there's no negative solutions. Now, it's not always this handy. It doesn't always work out where 1 is 0 to really help you, but still it's a skill that you have to know, okay? So the rational root theorem, this is how we get our list of possibles, okay? Meaning, so here is p, the factors of p, right? Plus 1, 2, 5, and 10, plus or minus the positive and negative, and q is the leading coefficient, and we want the factors of it. All of my possibles come from putting all of the factors of p over all of the factors of q. Okay, so once they do this, they do 1 over 1, 1 over 2. I'll show you how I do my list. I do a little bit different of a pattern, but when I do my list, I follow a different pattern. But it doesn't matter what pattern you follow, as long as you're following a pattern. It just so you don't get yourself confused, okay? So we want all of the factors of p over all the factors of q. So once they do that, we have this simplified list. Okay, so the simplified list, this means this list means that if this has a rational zero, okay, now remember we have irrationals and we have imaginaries that are also possibilities, but if this has a rational zero, okay, meaning something we could find in the calculator, it has to come from this list. That means we no longer have infinite possibilities. It has to come from that list. Okay, so if this was the list for the previous problem, we know that we can immediately eliminate all of those negatives because it says it can't have a negative root. Okay, so that is helpful here. All right, so this is the list you will pick from to find the zeros for those higher order polynomials. This is the list that you will pick from to put into your synthetic division. Okay, so let's look at some examples. Number 1. Okay, so first it wants us to do rational root theorem. We can't pick from a list if we don't have a list. Okay, so rational root theorem. P is equal to the constant, and we don't care if it's positive or negative because we're going to put plus or minus in front of it anyway. So all of the factors, 1 and 10, 2 and 5, Q would be the leading coefficient, which is 1. Now I know there's another 1 here, but we don't want to do it twice. Okay, so rational root theorem is all of the factors of P over all of the factors of Q, right? So I have plus or minus. Now I personally like to start with, I'm going to change color here. Like I start with this one and I go, okay, 1 over 1 is 1, plus or minus, so 1 is done. 2 over 1, 2 is done. 5 over 1, 5 is done. And 10 over 1, 10 is done. That is personally the way I like to do it, but you don't have to do it that way, and you'll see it becomes a little different when there's more than just one to pick from. You just have to choose a method and stick with that method, okay? That way you don't forget anything. Because if you forget a step or you get them crisscrossed, you're going to mess up. You're going to have the wrong list. You're going to be picking from the wrong list. Just sets everything in kind of a tizzy, okay? So let's look then at number of possible positive roots. So this is Descartes. So Descartes says if I want to know the number of possible positive roots, I count the sign changes. So positive to positive, not a sign change. Positive to negative is a sign change. Negative to negative, not a sign change. So I know that I have one positive possible root. Okay? Now for negative, remember I have to sub in a negative and simplify. So I have negative x cubed plus 2x, negative x squared minus 5 times negative x minus 10. So a negative cubed is a negative squared is a positive negative times a negative is a positive, and the constant stays the same. So then from here, I count the sign changes. So I have a negative to a positive, so that's 1. Positive to positive, doesn't change. Positive to negative. So I have 2 or 0. Remember, we have to subtract 2 till we get to 1 or 0. Now, notice here, and we're going to practice this a couple times before I introduce the negative roots. But notice we have to have 3 zeros. Like I know that I have to have 3 zeros. I don't have to have 3 distinct zeros, but I got to have 3 zeros. Okay, so that means that I know I have 1 positive, and I'm either going to have 2 negative or 0 negative and 2 imaginary. Okay, so that's where the imaginary comes in, and as I said, we're going to practice this for a couple more problems before I really start talking about imaginary. Okay, so then this is the part that students kind of get frustrated with sometimes, because this is kind of a guess and check. Okay, so you have to just guess and check, and it gets frustrating because sometimes you're that person that picks the right number the first time or the second time, and sometimes you're the person that has to go through 3 or 4 numbers before you get it. It just happens that way. It just kind of is what it is. Okay, so I'm going to start with 1. No particular reason, just going to start with 1. So then I have 3, 2, 1, 0. So I have 1, 2, negative 5, negative 10. So bring down my first term. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 5 plus 3 is negative 2. 1 times negative 2 is negative 12. The remainder is not 0, so 1 is definitely not a 0. Okay, so maybe try negative 1. So we got 1, 2, negative 5, negative 10. 1 times negative 1 is negative 1. 2 plus negative 1 is 1. Times negative 1. Still not it. So we can try 2. So I have 1, 2, negative 5, negative 10. So 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. 8 minus 5 is 3. 6, negative 4. Still not it. See, I'm not always the best at it either. It just doesn't work out that way sometimes. So we'll try negative 2. So we have 1, 2, negative 5, negative 10. Multiply, so negative 2, 0, multiply, 0, multiply, and hallelujah. We have our first 0, or our first root. Our first root is negative 2. And I know that because the remainder is 0. Now the question becomes, well, how do we find the rest? Well, if this is a third degree, then this is a second degree. And we can do all kinds of things with second degree polynomials. We can factor them, we can quadratic formula them, we can complete the square. We have all kinds of ways to solve quadratics. So this becomes x squared plus 0x minus 5 is equal to 0. And of course we don't put 0, so we have x squared minus 5 is equal to 0. So I'm going to add 5. So I have x squared is equal to 5. Square root both sides, and I get plus or minus the square root of 5. So I have plus or minus the square root of 5. Okay. So if you notice, I have 2 negative roots, negative 2, negative square root of 5, 2 negatives, and 1 positive, positive square root of 5. Okay? So just as a little reminder, remember this is the dividend. This is the divisor. And this is the quotient. Okay, so it's just like a regular kind of a long division problem, just that it's in a different setup. Okay, dividend is what is being divided, divisor is what you are dividing by, and quotient is the answer to a division problem. Okay, so let's start over. Let's do another one. So again, we start with rational root theorem. Okay, so remember rational root is plus or minus p over q. So I need to know what p is. So p is my constant. Again, it doesn't matter whether it's positive or negative because you're going to put plus or minus in front of every term. So 1 and 5. Q is 2. So 1 and 2. So I have plus or minus 1 over 1 and plus or minus 1 over 2. And then 1 is done. And then I do 5, so plus or minus 5 over 1 and plus or minus 5 over 2. And then 5 is done. So I know that I've completed my list. So this is the list that I'm going to pick from to do synthetic division. So possible positive roots, I count the sign changes as the polynomial sits. So positive to negative is 1, negative to positive is 2, positive to negative is 3, and then we do subtract 2, so 3 or 1. Remember, to get negative roots, we have to sub in a negative. So I have 2 to the negative x, 2 times the negative x to the 4th. times, or minus 5 times negative x cubed plus 2 times negative x squared minus 5. So a negative to the fourth is a positive. A negative to the third is a negative times a negative 5 is a positive. A negative squared is a positive times a positive is a positive. So that means I have positive to positive, no change. Positive to positive, no change. Positive to negative, 1 change. Okay, so remember I have to have a total of 4 roots. So I either have 3 positive and 1 negative, or I have 1 positive, 1 negative, and then 2 or 0 imaginary, because remember it has to total to 4. Okay, so we need to pick from our list. You can pick whatever you want to pick. It makes no difference. Start wherever you want to start. Okay, so we can just start with, we'll just start with 1, okay? So 4, 3, 2, notice we're missing a factor in here, a term as the x term, so it needs a 0. So 2, negative 5, 2, 0, negative 5. So bring down the 2, multiply, add, multiply, add, multiply, add, multiply. So definitely not it. Okay, so let's try negative 1. So 2, negative 5, 2, 0, negative 5. So bring the 2 down. So negative 2, negative 7, multiply, add, multiply, add. Definitely not it. Okay, so let's try 1/2. Why not? So 2, negative 5, 2, 0, negative 5. So bring down the 2. So half of 2 is 1. Negative 5 plus 1 is a negative 4. Half of that is negative 2. That's 0. Half of 0 is 0. 0 plus 0 is still 0. Half of 0 is 0. And negative 5. So my remainder, so remember the last term is the remainder. And still not it. Alright, so let's try 5. So 2, negative 5, 2, 0, negative 5. So 5 times 2 is 10, minus 5 is 5. 5 times 2 is 25. 27, this is getting way out of hand. So I'm going to say that's definitely not it. Let's try negative 1/2. So 2, negative 5, 2, 0, negative 5. So half, 2 times a negative 1/2 is a negative 1, which would be a negative 6, which would be a positive 3, which would be a positive 5, which would be a negative 5 over 2. That's not it. So let's try 5 over 2. So 5 over 2, 2, negative 5, 2, 0, negative 5. So 5 over 2 times 2 is 5. 5 plus negative 5 is 0. Anything times 0 is 0 times 2. 5 over 2 times 2 is 5. 0 plus 5 is 5. That's 25 over 2, which is not it either. Something is wrong with this problem. And let me try -5/2. Let me make sure these aren't all imaginary. I may have mistyped the problem. No, they're not all imaginary, but looks like they're all irrational. Okay, I'm just going to move forward. This is obviously a typo. I will fix it on the notes. I obviously mistyped the problem. I apologize. Okay, so let's look at the next problem. Let me see. Yeah, I had to have mistyped the problem. I apologize for that. Okay, so let's look at this one. Rational root. So we have p is equal to the constant. So we have 124, 2 and 12, 3 and 8, 4 and 6. Q is equal to the first term, which is 1, thank goodness, which is just 1. So plus or minus P over Q, everything over 1, right? So 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, and 24 over 1. Now, you don't have to do it in numeric order. It just makes me happy to do it in numeric order. Keeps me in line. All right, so let's do Descartes. So Descartes says that we count the number of sign changes in the polynomial as it sits to know how many possible positives. So a positive to a positive, not a sign change. Positive to positive, not a sign change. Positive, 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 positive. Okay, so 0 because there's no sign changes. So negative, we got to plug in a negative. So a negative to the fourth is a positive. A negative to the third is a negative. Negative squared is a positive. 50 times a negative would be negative, and then the 24 stays the same. Okay, so positive to negative, 1. Negative to positive, positive to negative, negative to positive. So 1, 2, 3, 4. So we have 4, subtract 2, subtract 2. So this is helpful because I know now not to pick a positive number at all. So I'm going to pick a negative number. I'll just pick -1. So we have 1, 10, 4, 3, 2, 1, yeah. 35, 50, and 24. So bring down the first term. So 1 times a -1 is a -1. Plus 10 is 9. Minus 9. 35 minus 9 is 26. Times a -1 is -26. Plus 50 is a 24. -24. And hallelujah on the first try. Okay, so I know -1 is a root. Now, here's the problem. This is a 4th degree This is a third degree. Do I have any idea how to factor a third degree? No, not unless it's a difference or sum of cubes, which this is obviously not. Okay, so that means I need to do synthetic division again, but I don't want to do it on the original problem because that's only going to get me another third degree. Okay, so I want to do it on the quotient here so that I can drop it down to a second degree polynomial so that I can then use quadratic formula or factoring. So that means when I pick my number this time, I'm going to do synthetic division on the quotient. Okay, on this third degree polynomial so that I can get a second degree polynomial. Okay, so again, I'm going to pick a negative number. We'll just go with -2. So bring down the first term, multiply, add, multiply, add. So 26 plus a -14 is 12 times a -2 is -24. Things are looking up. So now I found another root. So -2. Now I have a second degree polynomial. So now this is x squared plus 7x plus 12. So remember I told you in an earlier video your last number should always be a constant. If it's not, you've done something wrong somewhere. Okay? And this miraculously factors, so no quadratic formula. So that means I have two more zeros or roots at -3 and -4. Okay? So I'm going to give you a second to do P over Q. You can pause the video if I happen to move a little quicker than you are, but you need to practice. Okay. So P is 10, the constant, 110, 2, 5. Q is the first term, so 1. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, right? This one is not sure what happened. This is also a typo. So we're just going to do possible positive and negatives. I'm not sure what I did in the note packet, but this one is going to have one irrational root and the rest are going to be imaginary. So that's not enough for you to figure this out just yet. So we're just going to do Descartes. So possible positives, count the sign changes. So positive to negative, that's a sign change. Negative to positive, sign change, positive to negative. So this is 3 or 1. Oh, maybe I just typed it in wrong. That would make me feel much better than another typo. Oh, hallelujah, I just typed it in wrong. Okay, I was losing faith in myself. Okay, so 3 or 1. And then number of negatives. So a negative to the 4th is a positive. A negative cubed is a negative times -3 is a positive 3x cubed. A negative squared is a positive, but times this negative is a negative. 13 times a negative is a negative, and then the constant stays the same. So positive to positive, no change, positive to negative, and then negative to negative, negative to negative. So we have 1. Okay, so my go-to is to start at 1, just kind of see where I'm at. So I have 4, 3, 2, 1, so 1, -3, -1, 13, negative 10. So 1, 1, add, multiply, add, multiply, add, yay! So we have a positive 1. Now again, we have that same problem. This is a 4th degree and this is a 3rd degree. We still don't know how to factor a 3rd degree. So we're going to have to do synthetic division again, but we're going to do it on the quotient because we want to knock this down to a 2nd degree. Now, a lot of you are probably thinking, well, I can just keep doing synthetic division until I find them all. Well, you're right, until we start getting to imaginary solutions and irrational solutions, because it's not going to come from this list. Okay, so be super cautious. So I'm going to pick negative 2. So multiply, add, multiply, add, multiply. Hallelujah. Okay, so I have my next root is negative 2. So then now this is a quadratic, so I'm going to write it as a quadratic. And this does not factor, because for this to be positive, it would have to be a negative 5 and a negative 1, which is not going to give me the negative 4. So that means quadratic formula. So x is equal to the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. So I have 4 plus or minus negative 4 squared minus 4 times 1 times 5. It's negative 4 over 2. So that's 4 plus or minus 2i over 2. And then that all reduces by 2. So 2 plus or minus I. So there we have our first imaginary. 2 imaginaries, I suppose. So notice we have 1 positive, 1 negative, and 2 imaginaries. Okay? That gave us our 4 roots. Okay? So number 5, p is 15. And again, you can pause these so that you can take your time and do it step by step. So 1 and 15, 3 and 5. So remember, it's plus or minus p over q. So plus or minus 1 over 1, plus or minus 1 over 2. 1 is done. Plus or minus 3 over 1, plus or minus 3 over 2. 3 is done. Plus or minus 5, plus or minus 5 over 2. Done. And plus or minus 15, and plus or minus 15 over 2. Okay? So I want you to do the positive. Positive, possibles, count sign changes. 1, 2, and then 0. Remember, we have to subtract 2. Possible negatives. Give you just a second. You can pause the video. A quick shorthand, if you're having trouble figuring this out or making mistakes, a quick shorthand is just remember that the sign of the leading coefficient, the sign of the coefficient, if it has an even power, it's going to stay the same. If it has an odd power, it's going to flip. Because remember, a negative to an odd is a negative, and a negative to an even is the same. So every even for 2 is going to stay the same. Every odd is going to flip sign, so it went from a negative to a positive, from a positive to a negative, and then of course the constant stays the same. So that's 1, 2, so 2 or 0. So let's go ahead and talk about number of imaginary. Now, so I have to have a total of 4, right? So I could have 2 positive and 2 negative. and that gives me my 4. But what if I have, like worst case scenario, if I have 0 and 0, that means I would have how many imaginary? 4, right? So I could have 0, 0, and 4. Or I could have 2, 0, and 2. Or 0, 2, 2. Or I could have 2, 2, and no imaginaries. So it has to be some combination that adds to be 4, okay? So let's start with roots. So I'm going to start with 3 this time. So we have 4, 3, 2, 1, 0. So 2, negative 5, negative 13, 25, and 15. So 2, 3 times 2 is 6. Add, multiply, add, multiply, add, multiply. Yay! But again, we have that same problem. It's a 4th degree, and this is a 3rd degree, and I still don't know how to factor a 3rd degree. So I'm going to have to do synthetic division again. So let's see. So in an effort to try and make the video a little bit smoother and quicker, I'm trying to pick values I know work. But it's not going so great. Okay, there we go. All right, so I'm not sure that's actually speeding things up when it takes me that long, but it is what it is. Okay, so we have, if I was in class, we would just guess and check, and I would let you shout them out, and we would go through it. But I'm trying to make it go a little bit smoother and not have to like swap pages on you a whole bunch. So remember, when we do synthetic division the second time, we need to do it on the quotient. So 2, 1, negative 10, negative 5. So half of 2 is 1, add. Half of 2 is 1. Oh, it's supposed to be negative. Sorry. It's supposed to be negative 1. Alright, so this would be negative 1, which would be 0, and this would be 0, which would be negative 10, which would be 5. Okay, so then now we have, this was a 3rd degree, so now we've dropped to a 2nd degree, which we can factor. So we have 2x squared plus 0x minus 10. And I'm just putting this here just to reiterate because I'm not in class with you. So we have 2x squared minus 10 is equal to 0. So 2x squared is equal to 10. Divide by 2, we get x squared is equal to 5. And square root both sides, we get plus or minus the square root of 5. So we have our 4 roots, 3, the first one we found, then negative 1/2, and then our irrationals, plus or minus 5. So we have 2 negative, 2 positive, no imaginary. Yet, well, we had 1 in the other problem, or 2, technically. Okay, so again, this would be a great time to pause the video, kind of work through this, and see what you can come up with. And we're also going to add number of imaginary. It's just something you have to do in college algebra, so I'd like to practice it. I think it's also on your daily grade. Yeah, it's on the handout too that you'll do. And it's just good practice to know this, okay? So again, I'm going to kind of go through, but I want you to pause the video and try some of these on your own, because without trying them on your own, you're not going to get that feeling of frustration, which sounds terrible, and I guess in a way it is, but it's just something that you definitely want to go through, because you don't want to get on a quiz or test and be like, oh my gosh, I'm doing everything wrong, when you're really not. You're just unlucky at picking numbers. Okay, so P is 15 and Q is 1. So I have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15, all over 1. Positives, there's no sign changes, so this is 0. Negative, remember, if it's an odd power, it changes sign. Even power, it stays the same. So it'd be negative x cubed, stays the same. Opposite sign, and then of course the constant always stays the same. So you have 1, 2, 3, or 1, because you subtract 2. So notice we have to have a maximum of 3 zeros. Now, so this is a little different, because now I can't have 4 imaginaries. But remember, imaginaries have to come in sets of 2. So I could have 1 negative and 2 imaginaries, or I could have 3 negatives and 0 imaginaries. Okay? So then we start the guess and check process. So I'm going to do negative 1. So 3, 2, 1, constant. Now when we start with a third degree, that means this is a second degree. So I have x squared plus 8x plus 15. And that factors. So we had no imaginaries. So our roots are negative 1, negative 3, and negative 5. Okay? Negative 1, negative 3, and negative 5. So same scenario, P is the constant. So lots of factors. Luckily Q is just 1. So everything over 1. So we count our sign changes. So positive to negative is 1, negative, 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 positive, so 2 or 0. So remember, to do the negatives, we plug in a negative, simplify, and count those sign changes. So remember, odd changes, even stays the same. So that positive x to the third goes to a negative x to the third. The negative x squared stays the same. Negative 14 flips to a positive, and the constant stays the same. So we have 1 sign change. So let's talk number of imaginary. So I know I have a negative root for sure. That only leaves me with 2 other roots. So I could either have 2 positives or 2 imaginaries, or I could have 0 imaginaries and 2 positives, or 0 positives and 2 imaginaries with that definite negative root, right? Okay. So then let's start. I'm going to start with negative 4 again. Just trying to make the video smoother. If I was in class, we would go through and do some more guess and check, but I need to get through, make it a little bit smoother in video form. Okay, so we have 3, 2, 1, and constant, so no missing terms. So 1, negative 1, negative 14, and 24. So negative 4 times 1, add, multiply, add, multiply. Now this one, We started at a third degree, so we are already at a second degree, so we don't have to do anything else. We just write it as a quadratic. I mean, we don't have to do synthetic division again, I guess is what I'm saying. So then this factors x minus 3, x minus 2, multiply to be a positive 6, add to be a negative 5. So we have x is equal to 3 and x is equal to 2. So my zeros, negative 4 are my roots, positive 3, positive 2. Okay. So same thing. Again, like I said, if you need to pause the video, do that, please, so that you can make sure that you're doing some of this thought process on your own to kind of double check yourself before you actually get to the daily grade, okay? So P, Q, luckily everything's over 1 again. We're going to do that number of imaginary as well. So positive roots, we count. So positive to negative, negative to positive, so 2 or 0. Negative, we have to sub in the negative. So remember, odds change, evens stay the same. So a positive x cubed becomes a negative x cubed. The x squared keeps the same sign, so it's negative, so it stays negative. Negative 9x flops signs, and the constant always stays the same. So I have one sign change. Now this means that I know I have one negative. So I can have one negative and 2 positive, that gets me 3. Or I can have one negative and 0 positive, which means I'm going to have 2 imaginary. But I always can have the option of having 0, right? And then I can have 2 positives. So I'm going to start with 3. 3, 2, 1 and a constant, so I don't have any missing terms. Bring the first term down, multiply, add, multiply, add, multiply. So again, if we start with a third degree, we have a second degree, so that gives me x squared minus 9 is equal to 0. Now you can solve or you can factor this. I mean, you're going to solve either way, but you can either add 9, square root both sides, square root property, or you can factor. It's the difference of squares. So you get x is equal to 3 and x is equal to negative 3. And so we have 3, 3, and negative 3. Now normally we don't write the 3's twice. You can write 3 multiplicity 2, but I just want to make sure that you understand there are 3 solutions to a third degree polynomial. Okay. Okay, so 2 more. So we have P. Again, we're going to do number of imaginary, so go ahead and do that. If you're pausing the video, make sure you do that number of imaginary. So P is 5 and Q is 5. So I have plus or minus 1 over 1, plus or minus 1 over 5. Plus or minus 5 over 1, and 5 over 5 is 1, and I already have 1, so I'm not going to put it twice. So positives, positive to positive, positive to negative, negative to negative. So I have 1. Negative, so flips sign to an odd, stays the same on an even, flips sign on an odd, and the constant stays the same. So negative to positive is 1, positive to negative is 2. Which means my number of imaginaries is also 2 or 0. Yes, because I can have 1 positive and 2 imaginary, or 1 positive and 2 negative, and the other one would be 0. Okay, so let's start at 1. Ooh, not in green. 3, 2, 1, and a constant, so no missing term. So bring the first term down, multiply, add, multiply, add, multiply. Yay. So this is a cubed, so this is a squared. So I have 5x squared plus 26x plus 5 is equal to 0. So I have x squared plus 26x plus 25 is equal to 0. So x plus 25, x plus 1. And we got to divide that 5 back out. So we have x plus 5 and 5x plus 1, which gives me x is negative 5 and x is negative 1/5. So we have 3 zeros or 3 roots as we anticipated. The first one was 1, then negative 5 and negative 1/5. So we had 1 positive and 2 negatives. So P is 4. And I know it's 2 and 2, but I'm not going to do it twice. So Q is 3. So 1 and 3. So we have plus or minus 1 over 1, plus or minus 1 over 3. And 1 is done. Plus or minus 2 over 1, plus or minus 2 over 3. 2 is done. 4 over 1, and 4 over 3. Okay, so then we need to do Descartes. We are going to do number of imaginary, so go ahead and plan to do that if you're pausing the video. Okay, so positive, positive to negative, negative to positive. So 2 or 0. So remember, for negative, we sub in a negative. Even stays the same, so that'll be a positive 3x to the 4th. The odd swap, so that'll be a positive x cubed. Even stays the same. Odd swaps, and the constant stays the same. So positive to positive, positive to negative, negative to positive. So 2 or 0. Okay, so with the imaginary this time, let's think about the most imaginaries we could possibly have. Well, if it fell where I had 0 positive and 0 negative, I could have all of my roots could be imaginary. Okay? Or I could have 2, 0, 2, or 0, 2, 2, or I could have 2, 2, and 0. Okay? Just remember, it has to be some combination of 4, right? So let's start with 1. We have 3. Say 4, 3, 2. Yeah, okay. So 3, negative 1, negative 8, 2, and 4. So bring the first term down. Add. Multiply. Add. Multiply. Add. Multiply. So this is a 4th degree, so this means this is a 3rd degree. So we're going to have to find another one. So let's look at So I know I need to do it on the quotient, which would be 3, 2, negative 6, negative 4. Bring the 3 down, so let's see if we can figure this out. Nope. That's it. So negative 2 divided by 3. Again, lots of guess and check goes into this, but versus me having you 4 pages of work to copy. Again, if we were in class, we would do this a little bit differently, but it is what it is. So there is some guess and check with this. You will have your small TI calculator, so you can use it to help you do a little plug and chug, maybe a little quicker for you. But usually synthetic division kind of pans out a little bit better. I just am trying to limit the amount of work you're having to copy. So negative 2 over 3 times 3 is negative 2. Add. Anything times 0 is 0. Add. And negative 2 over 3 times negative 6 is a positive 4. So now we have, this was an x to the third, so now this is a squared. So you have 3x squared minus 6. So we can solve 3x squared is equal to 6 divided by 3. So x squared is equal to 2. So x is equal to plus or minus the square root of 2. So we have our 4 roots. The first one, the second one, and then our last 2. Okay? All right, so basically the rest of this week is you practicing. So you have handout 1 to complete, which the key is attached. You have what was an activity to do around the room is listed. It's just a handout now, and it has a key with it as well. You can skip through the problems, do different parts of the problems. It's fine with me. Boundedness theorem, which is handout number 3. This one is practice for college algebra, because this is exactly what they ask you in college algebra. We don't use boundedness theorem a lot in this class, and I don't like really putting those questions on the test because we just don't practice it a lot, because they don't actually use it in application in college algebra. They just straightforward say, is this a lower bound? Is this an upper bound? So you have that on handout 3, which also has the key with it. And then you have your Unit 9 study guide. Okay, and the key will also be posted for it as well. Okay, so remember, this is a big college algebra skill. Do it again in Algebra 3. It is definitely used in calculus. When you start doing like summary of curve sketching, a lot of times when you have to find zeros and stuff, it ends up having to use synthetic division, quadratic formula, and so on and so forth. So it is something that will reappear, and it is something that appears on the ACT. So I hope you take it seriously. If you have any questions, of course, you know that you can get with me through Remind or Google Classroom. Okay?